Hey, it's your pal Globonaut and I'm back. More Kerbal Space Program, more Principia goodness, more Space Shuttle goodness. What's not to love? I know why you guys keep coming back, and it's for this right here. We're deploying the same payload as last video, which is that probe, but we're going to be using it this time to show off a Sun-synchronous orbit in Principia. If you've tried this in Kerbal Space Program stock, you'll know that the patched conics model doesn't allow for this kind of thing, because when you place a spacecraft in orbit, it follows the rails that the game's already calculated for you based on the gravitational pull of the body you're around. And that means if you place a satellite along the day-night boundary of Earth, eventually the day-night boundary will shift because the planet is going around the Sun. But with Principia, we can exploit some quirks of Earth and actually keep the satellite on the day-night boundary. There's a few satellites in real life that do this for observation or solar panel powering purposes, but I'm just doing it for fun here because I thought it'd be a cool thing to try and do. Now my space shuttle is just about capable of getting to a polar orbit, but it does run out of fuel a bit quickly compared to a more equatorial orbit. But that's easily fixed with a little bit of extra fuel in the payload bay, which I use to top the tanks up, and then the reaction control system is also useful for making the final adjustments on the re-entry burn there. And I'm actually completely out of fuel here, so I used my entire tank plus extra. I'm re-entering now, and coming back from a polar orbit in the space shuttle can be a task, because getting a ground track lined up with the space sensor is quite tricky. So some cross-range capability is welcome, and that's what I'm doing here. As some of you know, the shuttle used to do a heavy bank to help control its descent, and that's what I'm doing here. I'm keeping it a left bank for most of the flight to make sure that I'm lined up with the space sensor, but I purposefully overshoot it here so I can do another right bank and lose some more of my altitude more quickly so I don't overshoot the space sensor. And now you do that because by introducing a horizontal component to your lift, you can drop further through the atmosphere. You're not using all your lift to keep the spacecraft up in the higher atmosphere. Final approach now. Business as usual with this thing. It's about a 15-degree nose down approach usually is what I aim for, and that just keeps me stable on speed. And I can use the heads-up display there to really accurately plan my descent. So you can see here I'm just 45 degrees to the runway, so I've just got a gentle turn here, and then it's a 15 degree or so nose down, probably a bit more. Oh no, 15 degrees looks right. Brakes on, gear down. Bit of a bump. I do have to keep the gear quite stiff on this shuttle for some reason. The gear in Kerbal Space Program is notoriously bad, so that's how I've tweaked it to get it to work. And now we're back on the probe here. Now to get this to work, there was a lot of quick saving and quick loading, so you're going to see that in the video. But I did get it to work, and I found a strategy that worked for me eventually. What I'd do is let the orbits simulation steps increase, so I can see when my manoeuvre increases or decreases the rate of precession, and then I'd time warp forwards to see if that matches the precession of the day-night boundary. And then if it didn't, I'd quick load and make further adjustments. Most of the adjustments were decreasing my altitude, because I actually deployed it in a too high of an orbit. But then there was some adjustments with the inclination. I thought I needed to lower my inclination to 90 degrees first, but I realised actually that's decreasing my precession. So I then increased my inclination to about 97 degrees. And that let the bulge of the equator pull my spacecraft around a bit further, and eventually I get it right. Now there's one little quirk of this as well that I didn't consider, and that was the seasons. Obviously Earth's seasons change, and that also affects the day-night boundary and processes it sort of on a cycle as well, where it will come up and down depending on the time of year. I guess that's the best way to say it. No up and down in space, but it's hard to describe it any other way. You'll see it soon though. Now I'm not sure if there is a way to account for this with Sun-synchronous satellites, but if there is, I'd love to know it. Thankfully, it wasn't too much of a problem anyway, because even during the furthest point from the boundary, the sun was still visible for my spacecraft, which is the main goal I was going for. You can see here now, my orbit precesses around. This is the perspective of the satellite, so it's in day, coming up to the boundary, and you'll see the sun does start to dip a bit, but at the lowest points it's still visible. And I just let this process around a bit more, because it's following the daylight boundary as it rotates throughout the year, and that's about as far as it gets from the seasonal changes, and the sun is still visible, which you'll see in just a moment when I check it in the spacecraft view. But as you see, as it rotates around throughout the year, the orbit follows it. Now, I suppose there's probably a way to get this right with the seasons as well, but I wouldn't know. You have to put this in a retrograde orbit for it to work, but it seems that the seasons change out of sync with that. You can see it's still visible, but I'm sure there's a way to line it up and time it properly. But as you can see, it was still visible at the lowest point, and now the seasons are changing again, and actually it lines up once again. So I was really happy with the result here. That took a lot of effort, but I think it's pretty cool. Let me know what you think, and I'll see you in the next one.